Welcome to Static Talks. I'm your host, Dave Long, founder and president of StaticWorks. We make static control flooring. In our podcast, we'll discuss the threat static electricity poses to your business and how to address those risks. So one of the questions that comes up every day almost is, why do you contradict your recommendations? In other words, why do you tell some people the reason you need static dissipative flooring is such and such, and then tell someone else you need conductive flooring? And it's actually something that I think causes a little bit of confusion when people come on our website. It's confusing for them in general, even if they're not talking with us. So why do you really need to use a static dissipative floor sometimes instead of a conductive floor? So let's start out with the more simple part of it. What is a static dissipative floor? So a static dissipative floor is a flooring material that if you were to use an ohm meter and follow a certain standard, which happens to be ANSI, ESD, STM 7.1, which I'm not going to repeat over and over again, I'm just going to call it the test. If you were to do the test on a static dissipative floor, what you would discover is that that floor measured for electrical resistance less than 1 billion ohms, which is less than 1.0 times 10 to the ninth, and greater than 1.0 times 10 to the sixth, which we also call 1 megohm, which we also call 1 million ohms. So a floor that measures with a resistance meter between 1 million ohms and 1 billion ohms, we call that a static dissipative floor. A conductive floor is a floor that measures less than 1 million ohms, which is the same as saying 1.0 times 10 to the sixth. So if it measures less than 1 million ohms all the way down to zero, we can call that a conductive floor based on the same test I've already talked about.
So up to 1 million ohms of resistance is considered conductive flooring, and between 1 million and 1 billion ohms is considered dissipative. So how do customers know which to choose? So
why would you use one of these floors versus the other? Well, let's start with why you wouldn't, because that's probably more important for the podcast we're doing right now. So if you're putting flooring in an FAA flight tower or a 911 call center or a communication room or a hyperbaric chamber or any place other than electronics manufacturing, if you look closely at the standards, especially the grounding standards and the code and a lot of other aspects that have to do with the electrical properties of the building, lightning, surge protection, that sort of thing, what you'll discover is that in these areas, because you have energized equipment, in other words, things that are plugged in, those kinds of applications, the standards tell you that you're supposed to use a floor that has a minimum amount of resistance. That minimum amount of resistance just so happens to be 1 million ohms. And that doesn't matter which standard you're looking at for these kinds of spaces, because the one thing I can assure you of is there's a lot of consensus. So the FAA's newest document, FAA Standard 019F, the latest ATIS document, the Motorola R56 document, all of them tell you for these kinds of spaces that the floor has to have a minimum resistance of 10 to the sixth. That doesn't mean that a floor measuring 10 to the fifth wouldn't do the job. What it does mean, and this is kind of important if you're a specifier, is if you're going to specify a floor, why would you even think about deviating from the norm, the consensus? A floor that measures less than 10 to the sixth will also work, but it will not meet or comply. And I'm being very careful the way I'm saying this because some manufacturers don't have the engineering or the expertise to explain this in detail. So you'll see things when you look at spec sheets like exceeds R56, exceeds FAA 019F. You can't exceed those standards. And the reason you can't exceed them is they prescribe a range. There's a minimum and a maximum. How do you exceed that? If you go over, you're out of the range. If you go under, you're out of the range. I mean, think about it. You're driving down your favorite highway, and you're driving 90 miles an hour, and you get pulled over by your local police or your state police. And when they tell you you're going too fast, you say, "But officer, I was exceeding the range." You're going to get a big ticket, and they might even get mad at you for even saying that.
So by exceeding a specified range, you would essentially be failing to comply with the standard, and the result would be a potentially risky situation.
Well, think about what happens if you put a floor in a building and you wrote a specification and you knew that you weren't supposed to write the specification in such a way that it, quote, exceeded the range, but you did it anyway, and there's an incident, there's a computer burns out, there's a lightning strike on the building, and the power goes out, and they start looking at everything, and for some reason they question your specification. Why would you want to defend that to begin with? You don't need to. There are products that are built to meet these expectations, and those products are the ones that you should specify. So when you're looking at a end user space, a place where you're using computers, a data center, an operation that requires understanding the possibility of someone coming into the building and servicing the equipment. You don't want to put them in harm's way and have them kneeling on a floor, changing out circuit boards where the floor's electrical measurements are more conductive than they should be. So that's the answer to the question about why you wouldn't want to do something. So let's talk about why you'd want to do something in the conductive range. So I'm tasked right now, possibly, with designing a floor for a manufacturing operation where they're going to build circuit boards. And they need, let's call it 100,000 square feet of flooring. And I've been told that the floor and the operation itself has got to comply with an ESD standard called ANSI ESD S2020-2014. Simply said, that's the latest version of a document that tells you how to set up a program where you can handle electronic devices, including parts and circuit boards and final assemblies, and meet what would amount to being best practice expectations if you were ever audited for like an ISO audit, ISO 9000 or whatever the version of ISO is that you would have to meet.
And so these standard documents specify both an upper and a lower limit to the amount of resistance that's appropriate for this flooring?
So the one I'm talking about now for electronics, no. So in electronics assembly, because there are so many other protocols that are constantly monitored and tested, you don't need to have a minimum. You just need to have a maximum. So the maximum resistance of the floor in electronics manufacturing is 1 billion ohms. That's it. So everything less than a billion, all the way down to zero. So that begs the question, so why would it be more important to protect people in a space that has this other parameter than a place where people are going to work and put circuit boards together? And the answer is actually pretty simple. They have all kinds of strategic protocols in place, including testing people's footwear, making people wear special garments, having people wear certain types of wristwear that's connected to ground with resistors in it. The footwear has resistors. Everything in the environment is protected and controlled. So the possibility of things happening that would potentially hurt a person are diminished greatly just by the statistical protocols that are put in place.
Do the standards documents assume that everyone in the space will be wearing some kind of ESD footwear?
That's the million-dollar question. No. What they assume is that in the kinds of spaces we're talking about, call centers, flight towers, you're going to be wearing whatever kind of footwear you like to wear. If you like wearing athletic shoes, if you're wearing dress shoes because after work you're going somewhere, you want to look, I don't know, for fashion reasons a certain way, those kinds of shoes don't even have any conductivity. Which brings us to a very important parameter, which is the floor also has to have the ability to prevent or mitigate or inhibit the ability to charge up in the first place. And that's why I complimented your question, because when you put a floor in a particular type of environment, sometimes the conductivity is not as important as the floor's ability to prevent the charge in the first place. So let's go back to the communications applications like the dispatcher operation. Those floors have a minimum resistance of 1 megohm. Whether they had a minimum resistance of 1 megohm or 10 megohms really doesn't matter as much as will that floor add to the generation of static or inhibit the generation of static. Well, we know that because they're going to be wearing regular shoes in those environments, the floor obviously has to have a place to take a charge, but it also can't contribute to the charge to begin with. So we're not looking for that floor in a dispatcher operation to be a dead short to ground. However, in a electronics manufacturing application, completely different set of parameters. We're going to be assuming, because of the way these organizations operate and the standards they have to meet, that when a person arrives at work in the morning, or whatever shift they're working, they are going to have to put on special footwear. The special footwear that they wear will have conductivity also. That could be ESD shoes, could be what they call an ESD foot strap, it could be a moccasin of some sort, or in clean rooms they wear special booties that have conductive materials on them, but they will be required as part of their protocol before entering what they call the ESD protected area to wear special footwear. That allows for that type of application in that industry to put together a parameter which states that when the floor is tested based on a particular method, that when the person is wearing the special footwear, they will never generate more than 100 volts. With regular footwear, that wouldn't even be possible. So that's why organizations like the FAA put out these ground and surge protection documents and include clauses like you cannot use conductive flooring, and the reason you can't use it is because if that kind of flooring is used around energized equipment, and they define energized equipment pretty clearly, it's things that are electrical, so your laptop, your cell phone charger, anything in the room that's electrical, you could be in harm's way if the floor is too conductive. So we make a pretty strong stand on this. I'm not telling you you're going to get hurt if you use these materials. What I'm telling you is that because there are alternatives, it makes absolutely no sense to be deviating from standards. I mean, we could think of so many different examples in building materials. And I know enough about the architectural community. It's not a community that intentionally specifies things just to differentiate themselves from what they're supposed to do. It's the other way around.
And do all of the ESD flooring products on the market protect in the same way from these type of risks?
So when you look at static control flooring, one of the things you might see in a brochure is that it's the responsibility of the owner or the specifier to determine the suitability of the product. Now, on top of that, some manufacturers will go so far as to make the statement that their product meets or exceeds a certain application. And depending upon your definition of semantics, you might say that if they name meet or exceed and they name 5 standards, you're not really sure which ones they're meeting or exceeding. But I'm not a lawyer. I'm not here to argue semantics. What I am here to tell you is that if something is supposed to fall between X and Y, and it's either less than X or more than Y, it doesn't meet. We hope you learned something today. If you have questions about the podcast, give us a call at 617-923-2000. Even though we specialize in solving problems with flooring, if you have a question about static discharge, how to install a floor, how to test the floor, we'll be glad to help you. Thanks for listening.